I'm Ronald Cohen at the Carnegie Institution, and we use big computer calculations to understand behavior of materials in the planetary materials like the deep Earth. And I'm going to be talking about iron in Earth's core and the geodynamo. Now, the geodynamo generates Earth's magnetic field, and Earth's magnetic field is very important because without it, no life could exist on the surface of the Earth. But how does the magnetic field get generated? It gets generated by flow of liquid iron in Earth's core. Now, people thought they understood this process pretty well. In fact, this picture shows a simulation by Gary Glatzmar at Los Alamos of how the Earth's magnetic field is generated. But it depends on the properties of iron in Earth's core. And very recently, some new calculations suggested that the thermal conductivity of the iron in Earth's core was so high that it was impossible for the normal geodynamo to work. And so this caused a big problem, and people have been running around trying to figure out how to make a geodynamo or any dynamo work so that you can have a magnetic field for the Earth. Other planets have magnetic fields too, like Mercury, Mars and the Moon have had magnetic fields, and other planets do too. So how do these magnetic fields get generated? Well, all of the previous work, including work we did previously, was based on the idea that electrons scattered off of vibrating atoms, and that's what generated resistivity in iron. What we looked at is and in fact that's shown here, that's called electron-phonon scattering. And electron-electron scattering was believed to be only important at very low temperatures, like a little bit above absolute zero, and whereas the center of the Earth is extremely hot, like 6,000 Kelvin. So, but what we did is we calculated this electron-electron scattering and found that it's very large. We used a new method which couples many-body theory with theory for electronic structure of crystals in a self-consistent way, and includes every possible way that electrons can scatter off of each other. And these are huge calculations that require big supercomputers. And the net result is we found that, that this electron-electron scattering was so important that it actually fixed the problem with the geodynamo. So we now understand how planetary magnetic fields are generated, and also our new results agree well with experiment.